All right, so completing the square. So I kind of wanted to jump into it yesterday, but we are taking it nice and easy. So we'll start off with what we were doing yesterday. So we've got x squared minus 10x plus 25 equals 20. So these ones we had yesterday, we were told that this left side was what kind of trinomial? All right, so maybe let's put that label above this. So this is a perfect square trinomial. That was what we put on our yellow sheet yesterday. So it's a perfect square trinomial. We were told that. And so that means this is going to factor into a binomial squared. So that's why we were making this one binomial and we were squaring it. We take this first sign, negative, and I take the square root of this number, so 5. And then I still keep it equal to 20. That was helpful because, Abby, what can I do next? Yeah. Because before what we said is if I had this problem, the only way I could solve it was potentially factoring, and a lot of those don't factor. In fact, that one wouldn't have factored if I had tried. But now, since I know that this is a perfect square trinomial, I can factor it. Now I can square root both sides. So I get x minus 5 equals plus or minus. Not a perfect square. Do I need an I? No, but there is a perfect square in there. 4 and 5. So it becomes 2 square root of 5. Move our 5 over. Getting good at this. Keep the 5 in front of the plus or minus. 5 plus or minus 2 square root of 5. Stop or keep going? Stop there because this has a radical. If this part has a radical or an I, you have to stop. If it's just a number like we saw in the homework problems we went over, that's when you keep going. Yeah.
So for when it has the radical 20, I know just by looking at it, that would have been 2 radical 5. Do you still want us to show the 4 and 5?
For a little bit longer until we get through spring break, I want to see you breaking that up. But after we get through spring break, after we get through the last test of this chapter, or after we get through that, then you can start to do some of those easier ones in your head. Okay, so this is where I was starting to get to yesterday. So we talked about how these trinomials are not very common. When we think about all those practicing factoring problems we didn't get to write a binomial squared very often. Usually it was something like x squared minus 5x plus 6, and it factored into 2 binomials, and they didn't match. So these perfect squared trinomials are fairly rare. So I said, well, wouldn't it be great if we could make them or generate them? So that's really what this completing the square process is. So what we were doing yesterday, it wasn't completing the square, it was using these perfect square trinomials. So this is what's going to go on our yellow sheet. That's what I wanted to put on yesterday. So on your yellow sheet, completing the square means you're going to make a perfect square trinomial. Completing the square means you're going to make a perfect square trinomial. If you got a new yellow sheet today, you might want to remember to put your name on it somewhere just in case it falls out or goes flying across the room. And my recommendation as we're getting closer to the end of the year, you won't be able to use them next year on quizzes or tests, but I have a lot of people still hang on to them because they are very helpful study tools for you for next year. So I would hang on to them. Some of you've got a real work of art there and have a lot of good study material on those. We will come back to this, but let's first go back to our notes. So we'll come back and we'll put an example, but let's do one on our notes first. This goes on our notes. So this is how the book writes it. It says x squared plus 6x plus c. So they're going to have two terms, the x squared and the x term. And then what that c is they're like, well, we want you to generate this number right here to make it a perfect square trinomial. Well, I think what's easier to write is to write it as x squared plus 6x and then to put a blank. And that's how I'm going to write the rest of them. So anytime you see a c, just put a blank. Now, let's think about this perfect square trinomial. So this number, when I think about my binomial, it's 2 times the number that's in here. This number is the square root of the number that's in here. Well, if I could get the number that's in here, and then I could square it, maybe I could get this number. You got an idea?
No, I just have a question.
Oh, okay. What's your question?
Can I sit right here just so I can see?
Yes. And that can be your permanent seat if you want.
Okay.
Okay, so we need to figure out maybe how to get this number because I know this one. So if I go down here, this number is half of the x term. And then I could go over here to get that blank number. So here's what's happening. I'm going to take half of this. That's 3. And then if I square that, that's 9. Let's see if that really did make that binomial squared. So let's see. If I take x, I take the first sign, positive. I take the square root of that, 3. Then I do my little check. 3 times 2, is that 6? Yeah. That's the process for completing the square every time. We're going to find the b term. We're going to take half of it. We're going to square it. It goes in the blank. Now, there is another part to it. So before we come back and before we put an example on our yellow sheet, I want to get a little bit farther into our examples. So another example of filling in the blank, of making the perfect square trinomial. We've got x squared plus 10x plus blank. Our goal is to fill in the blank and make the binomial squared. And of course, I'm a math teacher. I want to see our work. So we're going to show taking half of this.
You have to put that down.
Yeah, I know. So we're going to take half of this. I don't need to see the actual divide by 2, but I want to know what half of 10 is. So it's 5. I want to show that you're going to square it. And so I need to see 25 in the blank. This is what you're writing down. That's not a big deal. You can suck it up. You can put that one in, I think. All right, then we're going to write the binomial. Here's why I'm asking you to write it down. Sure, on this one, it's not a big deal, but some of these are going to get a little more challenging. This number is what goes in your binomial. So I know my binomial is x plus 5 squared. I don't really have to think about it like I was guessing and checking before. I know that this number is that number in my binomial. That's going to be more important in a couple minutes. This one I've got x squared minus 16x plus blank. What's different about this one than the last two? It's negative. So the only thing that's different is when I take half of it, it's going to be negative 8. What kind of number do I get if I square a negative? I still get positive. Because a negative times a negative is positive. This number is always positive. So a positive times a positive is positive. A negative times a negative is positive. So we're always going to be adding that c. And so this is going to be 64. So I don't really have to think about it. I know it's going to be x. Oh, it's going to be minus 8 squared. And again, right now I don't have anything that's going to be equal to.
What both percentage?
Say it again.
What both percentage?
So if this sign is negative, it will never be a perfect square trinomial. So you can't have it. That's a good question. So that sign, this sign right here, will always be positive. And what they're giving us is they're really just giving us either a positive or negative here and that term. They're giving us this. We're filling this part in. So we're making that plus that number. So we're adding that part in there. So it has to be positive. Good question. This one. X squared plus 5x plus blank. This is where the work becomes a little bit more important. Why? It's odd. It's not going to go evenly. So we panic for a second because it's going to be not a decimal, but a fraction. But I think we can do this even without a calculator because we know these steps. We're going to take half of 5 and we're just going to leave it as 5 over 2 since it doesn't divide nicely. And then we're going to show that we're going to square it. When you square a fraction, you square the top number and you square the bottom number. Well, we can square 5, we can square 2. I can do both of those in my head. It's 25 over 4. If I asked you to try and factor that trinomial, that would be super challenging. If I asked any of the math teachers down here, just walk down the hall and say, hey, factor this, they'd be, whoa. But it's not hard for us to factor because we know what the binomial is going to be. We know it's going to be x plus 5 over 2 squared. That's why it's good to be in the habit of writing that number because when we get the challenging ones, we know what it's going to be. All right, so we're kind of getting in the routine. Let's see how this applies to actual problems. Because now we're going to solve by completing the square. So we have solve by graphing, solve by factoring, solve by square root. Now that idea of having these perfect square trinomials leads into solving by completing the square. So it's taking what we were doing yesterday and generating these perfect square trinomials. We've got x squared plus 10x equals 12. So I need to make this side a perfect square trinomial. So what I'm going to do is I'm going to make it x squared plus 10x plus blank. That's why I think that blank is a lot easier than the c. Here's another reason why I think the blank is helpful. Think about equations. If I add 5 on this side, what has to happen over here? I have to add 5, right? Well, I'm going to add something, and I don't know what yet, so I'm going to add a blank. So I'm going to put a blank over here. That way, whenever I fill in the blank on the left, I hopefully remember to fill in the blank on the right, so I keep my equation balanced. If I don't put those blanks on both sides, a lot of times I see people forget to put the number on both sides. And then your equation becomes unbalanced. You get the wrong answer. Okay, so now here's that process we were just doing. It hasn't changed. We're going to take half of 10, 5. We're going to square it, 25. But it goes in both blanks, so it goes on both sides. So same process still. This is now a perfect square trinomial. So I'm just going to remind myself of this. This is now where it looks like just the problems we were doing yesterday. So that problem factors into x, we'll use that number right there, x plus 5 squared. What do you think I'm going to do on the right? Add those numbers. 37. Hello? Now what can I do? Square root both sides. All those noses I see, I'm giving up for today. Tomorrow I'm going to crack back down. Just make sure I don't see your mouth. Really cracked out. I'm recording this. All right, so we've got x plus 5 equals square root of 37. What did I forget? Good job. So distracted, scarred by all those noses I was seeing. All right, subtract that 5 over. It's going to go in front. There's no perfect square or I that I needed to worry about. So negative 5 plus or minus square root of 37. And we are going to continue to leave everything in radical form. Your book will say to put it in decimal form. No, we're going to continue to work on simplified radical form. I think we need more practice with that. All right, let's keep going. X squared minus 12x. Oh, what could I do right away? Maybe as I was writing it down, if I thought of it. Yeah, let's put a blank. So if you think of that as you write a problem down, I'm okay with that. So if you think of it as x squared minus 12x plus blank equals negative 5 plus blank, I'm okay if you want to do that. If you don't, it's not a big deal. You just write one more line. I know Logan likes to conserve space as well as a few others of you. Now we complete the square. So again, the completing the square steps, we find the x term. We're going to divide by 2. What am I going to put? Good, negative 6. That sign is going to be, like so many times, what we make the mistake on. So watch those signs. When I square it, it's always going to be plus that number. So positive 36. That's why we put plus the blank every time. So my binomial is going to be x, I use that negative sign, x minus 6 squared. Negative 5 plus 36, 31. Once we get here, hopefully we're like, oh man, we've been doing these problems for a while. I'm good to go. Square root both sides. You're going to find probably a lot of these aren't really ones we can simplify. This one isn't. Square root of 31. Add the 6 over. 6 plus or minus the square root of 31. Okay, a little bit different. X squared plus 5x plus 4 equals 0. Couple issues on this one. Anyone see one thing that maybe is different? The 4, I don't know if someone said something different. So 0. So both of those are tied together. So anyone have an idea of maybe what I should do first? Carly? Okay, so our first step, and we'll go back and we'll put this on our yellow sheet. Our first step is we need to get the x squared and the x terms by themselves. So if there's a number here, whether there's a number on the right or not, I don't really care. But I need to get the x squared and the x terms by themselves. So let's subtract that 4. So we're going to make it x squared plus 5x. Now, obviously, I've done this a lot. I've already done it with the other 2 groups already this year. I've done it for several years. I know I'm going to be ready for the blank. Once you kind of get in the habit of doing these problems, you'll realize you're going to be ready for the blank. So you could start putting it. So negative 4 plus blank on the other side. Here's where we might see the other issue. We see it yet? Oh, fraction. Now, we can do the first part without a calculator, but I do think we're going to want our calculator for some of it. So if your calculator's not out, dig that sucker out. This was actually the fraction we saw earlier. So I took half of 5. It was 5 halves because it didn't divide. Squared both of them. I forgot my squared. So 25 over 4. This part I can handle. It's x plus 5 halves squared. This part, oh, well, I can't really handle it. So in my calculator, I'm going to do negative 4 plus 25 over 4. So put that in your calculators. This is important because I want to make sure we all know how to handle our calculators. So negative 4 plus 25 over 4. What'd you say, Amber? What is it? So not positive?
Yeah.
So 9/4. But is that what your calculator gives us right away?
Yeah.
So yours maybe, because his is a little different than the rest of ours. What does the typical calculator give us?
It gives you 2.25.
Oh, so it gives us a fraction. Now, if you typed it in as a fraction, it might give us 2 1/4. Neither one of those I like. I know usually I'm okay with this one, but here I want it as an improper fraction. I'll tell you why in a second. If you get either one of these, we need to know how to change it. So if you get a decimal, the first thing you have to do is you have to hit second and the PRB button and hit equals. And you're welcome to put that on your yellow sheet. I see Carly doing it right now. That's fine. So change a decimal to a fraction. It's the second and the PRB button. So decimal to fraction. Second and PRB. To change a mixed number to improper, because that's going to be the next step, you hit second and the fraction button, the ABC button. So hit second and the ABC button, and then we should all have 9/4. And then I'll be able to show you why that's so important. So fine to put both of these things, whoops, I didn't cross it off. Both of those things on your yellow sheet if you want. Those are things we should know how to do with our calculators. So I've got x plus 5/2 squared equals 9/4. What's my next step? Square root. Here's why that fraction is so important this way. When I take the square root of a fraction, we know this. If it's like this, I just take the square root of the top and the square root of the bottom. If I had a decimal, well, I have no way how to do that. If I have a mixed number, I can't just take the square root of each part. That is not how that works. So that improper fraction allows me to take the square root of the top and the bottom. So now I can do x plus 5/2 equals plus or minus. Oh, I like this one even better because what's the square root of 9? And then what's the square root of 4? 2. Sometimes the top number won't be a perfect square, but the good news is the bottom number always will be. In fact, it's always going to be 4. All right, we're not done. We got to move that 5/2 over. So negative 5/2 plus or minus 3/2. Oh, and stay with me. You awake?
Yeah.
Okay, our eyes are getting a little heavy. All right, good. Keep going. Oh, keep going. All right, so we've got to do negative 5/2 plus 3/2. Let's see, that's negative 2/2, so that's negative 1. Negative 5/2 minus 3/2, that's negative 8/2, so that's negative 4. Whew. That was a fun one, wasn't it? I don't know about that. I don't know that it was fun either. That was an interesting one. We'll leave it at that. All right, I want to do one more, and then I want to go back and get some directions on our yellow sheet. Oh, I was ambitious today. All right, here's the next one I want to do. 3x squared plus 6x plus 18 equals 0. 3x squared plus 6x plus 18 equals 0. All right, this has something else different. Tell me.
So GCF?
So there is a GCF. Now, it's not that it's a GCF, but all the problems I give you, it will look like a GCF. So it's that there's a number in front of x squared. And so when we first started seeing GCFs, it was also the number in front of x squared because that makes the problem a little bit easier. So remember how we divided by that number? We're going to divide by that number. Whatever's in front of x squared, and we're going to divide all the way through both sides of the equation. And the good news is she's right. It will be a GCF. And so if I divide on both sides, what do you think happens? Do you think I need it or do you think it disappears? It disappears. I don't have to pull it out. When it's just on one side, that's when I pull it out as a GCF. But if I can divide it on both sides of the equation, it's gone. So I divide by 0, poof, it's gone. So now I just have x squared plus 2x plus 6 equals 0. Okay, now we're going a little bit better. Now it's kind of looking like the last one. Chris, do you remember what I need to do before I complete the square now? I gotta get something over on the other side. Yeah, how do you want to move it? All right, so we got to get the x squared and x by itself. So let's subtract 6. So x squared plus 2x, let's put a blank, equals negative 6 plus blank. All right, here comes the completing the square. Half of 2 is 1, squared, 1, both blanks. So we're going to have x plus 1 squared equals negative 5, square root, both sides. X plus 1 equals plus or minus. What do I need? Good. No perfect square in there though. So plus or minus I square root of 5. Move that 1 over, negative 1 plus or minus I square root of 5. Once you have that, we'll go back to our yellow sheet and put some steps. So right underneath, you're completing the square part. So wherever you have complete the square. So first, you want to divide by the number oops, sloppy. That is with x squared. Now, certainly there are problems out there. If you divide by the number that's with x squared, you're going to get fractions. I am not going to give you any of those. It's going to divide all of the terms nicely. Step number 2, get x squared and x by themselves. If I could write today, that would be great. Add plus blank on each side. I don't know what's happening over there. Take 1/2 of the bx term, square it. Hang with me, you're going to be happy because I'm going to shorten your homework. Square it. Put in both blanks. I think that's enough to kind of get you going. And then I'll put your homework, don't put this on your yellow sheet, but I'll put your homework up here too. It is in the book, page 195. Let's do 6, 7, 9 through 11, 26, 33, 35, 39. So I shortened that up quite a bit, so make sure you write that down before you leave.
What does that word say at the end of 2?
Themselves.